Hey friends, hope you're doing fine. Today I'd like to dive into column transformer, which is a really neat feature in scikit-learn which helps us to optimize our scikit-learn machine learning pipeline. So let's have a look at that. So at first I get started with importing the relevant libraries like NumPy, Pandas, and here from scikit-learn compose I'm using the column transformer. You can also use make column transformer. It's maybe a little bit easier to read, but both actually work the same way. And I also imported pipeline and make pipeline, and then also impute to fill in missing values, as well as some kind of scaling techniques like standard scaler and one-hot encoder. Then I fetched a dataset from fetch OpenML. It's also part of scikit-learn. So if you want to follow along, you can also import the dataset from here and then do exactly the steps as I've shown here in the video. So I'm using the Titanic dataset, quite popular. Also, it was or has been a Kaggle competition, but that's of course some time ago. But here it's available for free for us, so we can download it as well as using as frame to get it as a data frame and also return the X and the Y because we also want to have the target. The target in this dataset, just briefly, is whether a person has survived or whether he or she has died on the Titanic. So here I just took a look at that, and then I basically stored both, so the features and the labels in X and Y, and then I simply checked here whether the features are missing or whether the data is available. You can clearly see that, for instance, age, okay, 20% more or less, there is no age for this person available, so the information is missing, and fare is missing, but especially cabin, for instance, here is very high, or also boat is very high, body is very high, so these information are more or less not available. And if, of course, if something is missing like 0.9, so 90%, then of course it makes no sense actually to use this as a feature. But this is, for instance, some information you get by simply checking the amount of missing features. Quite easily you can do that and then figure out whether you want to keep this feature or not. There are other techniques to reduce the feature or also check out feature importance and stuff like that, but those are just an example here. Our main focus is back on the column transformer and how we can apply it. So what I did was I selected here the D types. So I want to store all the numerical D types and actually the column names in numeric, and all the categorical, so the object D types in this categorical. And then I simply dropped one feature, in this case, which was the name, because even though the name of the person is not missing, the name itself does not really have any value, at least from my point of view, on telling us whether someone survives or not. So if his name is Ben or Frank, it doesn't really matter, right? Okay, so then I here checked simply what's inside, and you can clearly see that here I stored all the relevant columns in here. And then we can create a pipeline, like for instance here, we can use make pipeline or pipeline. The difference, as I said, with make pipeline, we do not need to specify tuples. We can use this directly like that. Otherwise, we would have to specify tuples with the name if you use pipeline. But what I did was I imputed here. I tried the KNN imputer and then a standard scaler here. And that's my pipeline here. And then I also made here another pipeline. I just called this N pipe because it's numerical features, and this is C pipe because it's categorical features. And that's why I also had to use another imputer strategy here. I used simply the most frequent one, right? So I'm filling missing values with the most frequent value of this specific column. And then I'm doing one hot encoding just to get a numerical representation of the column. And this is basically my categorical pipeline. Now I have two pipelines here, the numerical one and the categorical one, which look like that, as we see here. And my final pipe here is exactly this make column transformer. Because the make column transformer, or you can also use column transformer, but then you would have to specify another argument in the tuple, which is the name. So I skipped that. So we're referring to make column transformer here. And then I can say I want to have this one here. And the main benefit is that this make column transformer allows us now to apply the numerical pipeline on the numerical features, and here the categorical pipeline on the categorical features. That's mainly the advantage here. And if we have this, then we basically have the final pipe, and then of course we can fit this pipe in this case I fitted here only the categorical pipeline, but we can fit this afterwards here, make pipeline, that's the last one here, when we say we want to first use our final pipe, which contains again the make column transformer, and the second is then we use any kind of machine learning algorithm. In this case, I'm referring to the logistic regression. It's an oldie but goalie and oftentimes very efficient. So there's no need to use any kind of complex neural network for that. And let's have a look at the training pipe. So you can see that we got actually pipelines, and those pipelines are put into the column transformer. And the column transformer is again then one part or one element of the final pipeline, which also includes our machine learning model. And that's what it looks like. And then we can fit it here. This is that. And then of course we can score or make prediction. In this case, I scored here, and I got here a score of 99.31% on this training data. So you can see this is quite efficient and allows us to use different kinds of transformations or pipelines applied to different kinds of columns in the dataset, and we get a pretty good result actually, right? So our neural network would not have been better than that. Probably not, at least. And of course, this is only on the training set. So of course, if we score it, I also scored it here with another algorithm. This was the second one which I used, and then I only received 97%. So it's up to us. Of course, you need to try out different algorithms, whether you use logistic regression or any other kind of classification like naive Bayes and KNN and so on, right? It's up to you. But that's it basically for column transformer. So you can see it's quite efficient. It's also easy to use. So if you know that this exists, then I would highly encourage you to try this out. It offers a lot of flexibility and allows us to do different transformations to different columns quite efficiently, right? And of course, this can also be applied on some kind of cross-validation, for instance. And of course, you would also normally at least use a train-test split for the training data and the test data for the scoring to find out what this actually can do for you. But as I said, the main focus was the column transformer here, and hopefully you got how that works. And of course, feel free to also try it out yourself. So thanks a lot for watching, and please subscribe to the channel if you have not done so far. And otherwise, stay healthy. And if you have any ideas, wishes, if you want to see more from a certain topic of videos, just let me know, and I will try my best to do that. Okay? So thanks a lot, and hopefully see you in the next video. Until then, best guys.